Everyone, I hope everyone is safe and doing good. Welcome back to my channel Record Rate with Mathematics. So in today's video, we will see how to prove root 2, root 3, 2 root 3 and a combination of two irrational numbers etc. as irrational numbers. That is, sum of two irrational numbers as irrational numbers and product of one rational and one irrational number is an irrational number. Such kind of problems. So we will be using the concepts that were taught to you in one of my previous videos, that is proving irrationality of numbers using the proof by contradiction or method of contradiction. We will solve and prove how we can prove whether a particular number can be considered as irrational or not. Without wasting any more time, let's jump right into the video. First problem is prove that root 2 is an irrational number, and this is the statement that we have. We will use the topic or the technique called proof by contradiction to show whether root 2 is an irrational number or not. For that, using method of contradiction or proof by contradiction, what we say is, we say that or we assume that root 2 is a rational number, right? We will assume that root 2 is a rational number. Now, what is the definition of rational number? A rational number can be written in the form of P by Q or A by B, where B is not equal to 0, right? Now, remember, there are a few things that you need to consider. This rational number, whatever we are writing it here in the form of A by P, this should be a co-prime, because it should not have any numbers that can be divisible by some other number. That is, HCF of A by B should be 1. We have assumed that A by B is co-prime or HCF is 1 and there is no common factor. What we need to do, we need to square on or remove this root and simplify it further, as in 2 is equal to A by B, right? I have removed this root and taken the square to that side. So can we not say that A square is equal to 2B square here? Right? Now, I have taught you a theorem that if there is a prime factor P, prime number P, and if it divides A square, then it also divides A, right? Using that, can we not say that A is divisible by 2 in this case? And B square can be some other number, right? We'll ignore B square by now, but can you not say that A square is 2 into some K, B square results in K. We assume K is some number and B square results in K. Okay, so now, since A square is divisible by 2 in this case, right, because this 2 can be taken here, right? A square is divisible by 2 in this case. Can we not say that A is also divisible by 2 using that theorem? If A square divides P, it can be divided by P, then A also can be divisible by P, right? So in this case we can say A is equal to 2K. Okay, now what we'll do is, we will substitute this A is equal to 2K in this, that is, I will be taking is here. We know for a fact that 2 is equal to A square by B square, right? Now here we know that A is equal to 2K from the simplification. So can we not say that 4K square by B square, right? Now I'll divide this. So we get B square is equal to 2K square. Yes. Again, using fundamental theorem of arithmetics theorem, we know for a fact that B is equal to 2K, because if B square is divided by 2, then B is also divided by 2, and assume this K square is some, we'll say, what did we take? C. Assume that this is B is equal to 2C, right? So, we have two statements here. A is equal to 2K and B is equal to 2C. But can you see what is common here? You have seen that there is a common factor here too. That means A can be divided by 2 and B can be divided by 2 also. But remember what we have said earlier. We've assumed that A by B is co-prime. We didn't give a chance to say that there is a common factor. That is the reason why we assumed A by B is co-prime. But here we can see, after further simplification, we can see that there is a common factor, that is 2, that divides both A and B, which led to the contradiction. A is 2k and B is some 2c, but 2 is common here. So this is the contradiction to whatever we have assumed earlier. Hence, using this proof, we can say that root 2 is an irrational number, because we assumed root 2 an irrational number and we found a consequence that disproves the statement and which led to a contradiction. Hence, we can say by proof of contradiction that root 2 is an irrational number. This is how you use proof by contradiction to say whether a number is rational or irrational. Okay, now in the similar concept, the similar line, let's see furthermore problems. The same way, let's try to prove whether root 3 is an irrational number or not. This particular technique to prove whether a number is irrational or not can be extended to any rational number, that is root 3, root 5, root 7, etc. So in this video, I will be covering root 2 and root 3. Okay, so prove that root 3 is an irrational number. We will assume that root 3 is rational, right? Using proof by contradiction. We will use the method proof by contradiction to show. And if root 3 is rational, then we know that root 3 should be in the form of 2 by A by B, right? It's because it's a rational number and B cannot be equal to 0, and there is a condition that HCF of A comma B is equal to 1, or AB should be co-prime. That is, common factor of A by B is 1. Now, if root 3 is equal to A by B, can we say that 3 is equal to A square by B square? Yes. So, can we not say that A square is equal to 3B square? Yes. Now, B here is, we took some number here, it can be a whole number. So, B here is whole number and B square results in some other whole number. So, we can assume that B square is some constant K. But see here, we have 3 as one factor here. So, can we say that A square is equal to 3K, and using the theorem, can we say that if P divides A square, then P also divides A? So, using this theorem, can we not say that if A square is divisible by 3, then A is also divisible by 3? So, using that, we can say A is equal to 3K. Now, using this statement 1, can we say substitute A is equal to 3K in this statement, root 3 is equal to A by B? Yes, 3 is equal to A square by B square and 3 is equal to 9K square by B square. So, we will get this as 3B square is equal to 9K square. Simplifying further, we get B square is equal to 3K square. If B square is equal to 3K square, consider this as some other whole number and consider this K square is equal to some C. Then, can we say that B is equal to 3C? And using the theorem which says that if P divides A square, then P divides A, can we say that if 3 divides B square, can we conclude that 3 divides B? Yes. So, this is 2. So, using these two statements, we found that there is a common factor 3 in these two statements. But we assumed that A by B is co-prime, that is HCF of A by B is 1. But here the common factor is 3, that is other than 1. Hence, this has resulted in a contradiction. So, we can say that if we assume root 3 as rational number, we found a contradiction that disproves this statement. Hence, we can say that the original statement root 3 is an irrational number is Okay, so this is how you prove the irrationality of numbers. So the next question is, show that 3 root 2 is irrational. We'll use the same method of by contradiction to solve the statement. So since 3 root 2 is irrational, we'll say that assume 3 root 2 is rational. So in this case, we know for a fact that rational numbers can be written in the form of a by b or p by q, wherein a, b, HCF of a, b is 1, that is co-prime. Right, that is, there is no other common factor apart from 1. Now, can I say that root 2 is equal to a by 3b? Here you don't square on both sides. We can do it very easily here. Root 2 is equal to a by 3b. Now, a and b here are integers, right? These are like lower level prime numbers. So, a and b are integers here. And you can also say that 3 is also an integer. It's a positive integer. 3 is also an integer here. Right. So, an integer divided by another integer will result in an integer. Here a is an integer, b is an integer and 3 is an integer. Right. So, what happens if we divide two integers? We'll get a rational number. We'll get a rational number or we'll get an integer only. Right. But we know for a fact that root 2 is irrational. Is it a fact or not? Yes, we proved it just before. We know that root 2 is irrational. And we know that when you divide an integer with another integer, you might result in a rational number. Right. So in this case, can you not say that this is contradicting? Root 2 cannot be equal to a by 3b because root 2 is irrational. But you know for a fact that this will result in a rational number, not an irrational number. Hence, by contradiction, we can say that, proof by contradiction, we can say that the 3 root 2 is irrational. Okay. This is how you prove whether 3 root 2 is irrational or not, using the fact that root 2 is an irrational number. Okay. Now the next question is, show that 5 minus root 3 is irrational. So using the method of contradiction, can we not say that assume that 5 minus root 3 is a rational number? Okay. And you know for a fact that a rational number can be written in the form of a by b, whereas the HCF of a comma b is 1 or it is a co-prime numbers. Right? Now, 5 minus root 3 is a by b. Can you take this here? What will get? And this here? What will get? 5 minus a by b is root 3. Or we can write this as root 3 is equal to 5 minus a by b. So root 3 is equal to 5b minus a by b. Right. Or yeah, let's leave it as is. We can write it like this or we can write it like this. You know for a fact that a and b are integers here. Right. Now, if you subtract 5 and a by b, you might result in a rational number. Right. Because it can be anything. A can be, if you, so for example, take 2 by 3, you get how much? 15 minus 3 is 13 by 3. And this is a rational number. Assume any values of a and b and you subtract 5 from that, you will get a rational number only as the answer. Right. But we know for a fact that root 3 is an irrational number which we just proved. Hence, we can say is an irrational number which is the fact. But here, root 3, the result of root 3 here, we are getting it as rational number, which is wrong. This is the contradiction. Hence, we can say that by this contradiction, we can conclude that 5 minus root 3 is an irrational number. It's the same concept. You just need to use that and prove whether whatever number they give using the operations also will be an irrational number. If you remember the points that I've highlighted in the beginning of the video, the operations, right? A rational number and an irrational number, if you add or subtract them both, you will get an irrational number. In some cases, when you add or subtract two irrational numbers, you might result in a rational number. But in this case, we proved that that statement is right. Okay, now let's see the last problem. We need to prove whether root 2 plus root 3 is irrational or not. Remember, when you add two rational numbers, you might get a rational number also as the result. But in this case, they are asking whether this particular addition results in an irrational number or not. Let's try using method of contradiction. So you'll say here that root 2 plus root 3 is a rational number, right? This is what we assume. In this case, can you not say that root 2 plus root 3 is equal to a by b, where the HCF of a comma b is 1, or they are co-prime numbers, that is common factor is 1, right? The same drill. Now can we not write root 2 is equal to a by b minus root 3? I'm taking root 3 long. Now let's square on both sides. So the easiest way to get rid of the square roots is to square on both sides. Remember this technique while solving equations. Now in this equation, after squaring on both sides, we get this as the result, first step, right? So 2 is equal to, can we not say this in the form of a minus b whole square? A minus b whole square is equal to a square minus 2ab plus b square, right? Now let's take b in the top and take the LCM. Now here we get what? Let's get rid of b, 2b square, a minus root 3b whole square, right? Now let's do it here. So 2b square is equal to a square plus 3b square minus 2 root 3ab into a, right? Now here a square, here let's take 2b square to the other side, plus 3b square minus 2b square minus 2 root 3ab is equal to 0. Yes, I'm just simplifying it. You can simplify in your own way. So a square plus b square minus 2 root 3ab is equal to 0, because I'm simplifying this further. Now can I write a square plus b square is equal to 2 root 3ab? Yes. Now I'm just taking the RHS here. A square plus b square? Yes. Root 3 is equal to a square plus b square by 2ab. So what do you observe here? The moment you have root in the equation, we'll take the roots and the number that has root and the remaining variables to one each side. Root 3 is a square plus b square by 2ab. You know for a fact that ab here can be any integers, right? And a by b is rational number. And you have performed many operations on those two integers. And can you not conclude that when after you perform these operations, you will get the result as a rational number? Yes, simplify, assume any rational number a by b, and then after you perform many operations, you will get the result also as the rational number. But we know for a fact that root 3 is irrational, which we proved just now. But here we are getting root 3 as rational, and this is wrong, or this is the opposite. This resulted in a contradiction. So we can for sure say that 2 root 2 plus root 3 is irrational, because we have disproved the opposite. Okay, this is how you prove whether a number is irrational or not. I hope you understood the concept of how irrationality and how to prove the irrationality of numbers, and also a small concept that I introduced in between, that is proof by contradiction. So hope you are very clear on this lecture, and if you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. So till then, I will see you all in my next video. Have a nice day and a safe week. Bye.